Hi, and welcome to the I Teach Myself podcast. My name is Matthew Miniman, and this is episode 91. What can transit systems teach us about RMM tools? So, transit systems. Cities like Tokyo, Singapore, Hong Kong, New York, Paris, Berlin. These are places that have massive amounts of people. They have just tons and tons of people. And not all those people own their individual vehicles. Not all those people have jobs that are close together. Not all those people have a lifestyle that facilitates walking to place. This requires them to be moved across their city, across their country, across their state, whatever it might be, across the region. And so, in a city like Tokyo, where there are approximately, 35 million people in that city, how do you get people from one point to another in an effective manner? Like, obviously, that's a lot of people to move from point A to point B. And of course, everybody's going to be crisscrossing around because not everybody gets an apartment that's like right next to them or buys a house that's near their work. So you have to move all of these people in a direction. You have to move them everywhere all at once, all the time. And not only that, but you have to do it in a way that is cheap and efficient. And probably the most important aspect is predictable. You have to have predictability with your transit system. Now, what do we mean by that? And predictability isn't just, hey, we know what's going to happen with the transit system. We know that it's going to stop at this time at this stop. Like, we know this bus or this train or this subway car or this whatever is going to stop at this location at this time. That is one aspect of predictability, and that is probably the most important. Making sure that you have a schedule that people can reference and identify and use to track where they can travel to and from is key. Like that's going to be kind of it all on a transit system. Having that path being predictable and knowing where they can go and how they can use it, that's going to be ultimately key, because if you don't have that, you don't really have a transit system. You kind of just have a Russian roulette with trains. That sounds awful. Fuck. Anyway, when you are writing a train system and you don't have any idea of where you're going or when you're going to be there, it makes it extremely difficult for you to trust that transit system. And, we'll give you an example. It doesn't matter if a train can travel between 2 points extremely quickly. Let's say you have two stops that are 5 miles apart, and the train says it can get you there in a minute. It doesn't matter if it can get you there in a minute, 5 minutes, or whatever. If it's 5 miles apart and you don't know when that train is going to arrive, or you can't predict when that train is going to arrive, it makes it nearly useless. Also, if you have no idea when it's going to arrive at your stop or whether it's going to arrive at the destination, you have to know both of those things, because even if it says it can get there in 5 minutes, but for whatever reason there's a delay on the track that causes it to stop for 15 minutes, that's kind of useless too. So the predictability of the trip is key as well. It's not just the predictability of when stops are going to occur, when I can get on a train, when I can get off of a train. It's about the predictability of how long that trip will take. It's also about predictability of where the trains will be and how many of them there will be. So predictability of space, basically, and predictability of use. And so when you are running through a train system and you are attempting to get on one, if there's only one car that's available that goes to the destination, or one car that travels to where you're going, it kind of makes the whole thing useless, because if it's so packed you can't get on or get off, that makes your stop completely unapproachable. It makes it unreachable. And so that predictability is going to be an aspect. That predictability of space is going to be an aspect. And that is kind of key. You have to plan appropriately. And when crafting a transit system, I hope they would plan for the number of trains to put at a specific stop, and then continually review that until they have a more efficient or most efficient method or measure of the train system. So, these are things that should always be evaluated by the people who are running the train system. So those are some of the predictable aspects of a train system or transit system that you need in order for that transit system to be good. I mean, there are other aspects that you can attribute to a good transit system, quote unquote, good transit system, like how accessible is it? Is it someplace where everybody can get to all at once all the time? There's also like, how clean is it? How safe is it? These are all things that can be attached as well to the best transit systems in the world. But they all also fall underneath that predictability. We can predictably say that each stop on this transit system occurs every so often. No place in this particular city is beyond X amount of feet from a stop to get onto the transit system, so on and so forth. So, predictability, it's key with operating a transit system or having a good one, at least. And that can kind of translate to an RMM. So I've talked about RMM tools a few times. And for those uninitiated who have no idea what the hell RMM means, it's remote monitoring and management. This is a utility or a set of tools that allows you to manage remotely your devices. So you don't have to be at the computer to manage it. But it's not just managing it like, hey, I can type in my username and password and click on things on the computer and get it to do things. No, it's beyond that. The remote monitoring and management solution also allows you to do things like control patching, control scheduled tasks, create automations for you to perform tasks without ever having to actually schedule them yourself. Also, your remote monitoring and management solution should come with a significant aspect of alerting, so you can identify when certain things or certain activities are occurring on your device. And there should be an aspect of logging and data retention with your RMM so that you can go back and audit what has happened. So you can see, if something malicious or something unexpected has happened with your RMM, or, if you have some conflict with an application, or your RMM is overriding something, or so on and so forth. And so with a good RMM, it should also be predictable. Like, you should be able to predict certain things with your RMM, such as you should be able to create a schedule, and that schedule should maintain itself. Like when you create a scheduled task within your platform, you should be able to predict that when the computer next turns on, you should be able to predict whether or not it will run that scheduled task. You should also be able to predict how much the RMM is going to utilize on your systems. So, it's not eating up all the CPU or all the disk space or all the memory or any of that. But you should also be able to predict how users are able to access the RMM. Like, you should be able to see they are required to MFA. They have, when a login event occurs, there should be a logging. There should be some sort of event in the audit log. When a user does something to a system, there should be an event in the audit log, so on and so forth. And so that should be predictable. You should have a ready and steady pace of information that flows from the RMM about the aspects of things that happen with devices and from users against the system. So then what else it makes a good RMM? It's not just, hey, I know how things are going to work, and I know how to make the RMM do the things I want. But it's also things like simplicity of use. An RMM should not be so complicated that when I'm looking at how to do something, I am left utterly incapable of performing a task, or I need 16 hours of training in order to use this RMM, because that makes it fucking useless. Because then I have to train somebody. If I'm going to hire somebody, I have to train them for 16 hours exactly how to use this RMM. An RMM should be flexible and predictable and intuitive enough so that I can give a basic layout of how the RMM operates, and somebody else can figure out the next steps. So, and that is similar to a good transit system as well, because there should be a transit map that shows how to get from point A to point B, and you can predictably identify the information in between. You should be able to see how specific routes are labeled, how they're traveled, and how they're traversed, and so you can predictably start identifying where you need to go, and the names stuff go, and how the transit system is named things, just like in an RMM. If an RMM constantly refers to something as an automation, then you should be able to predict how an automation is reflected in your RMM. However, if they refer to one set as automation and another set as components, or one set as components and another set as scripting, and it makes it very difficult to understand the difference between the two, then that can make your RMM sort of useless or extremely difficult to use and learn. And so that the difficulty curve of advanced use becomes a lot higher and lowers your utilization score on your entire RMM. So beyond that, what should make a good RMM? Well, good RMMs can be also classified as their ability to perform functions automatically. So some RMMs will limit the amount of functionality you get with automations. You can't necessarily automate your way into fully updating a system from one version to another. You can't fully automate things like installing antiviruses or things like that. You can't store files with the RMM so that you can run those files or download those files to the target machine so that they can then run it. You have to download everything from a third-party server in order to get that information onto a client machine. These are all things that can reduce the functionality of an RMM. So a good RMM should have that scripting capability fully utilized. Like, there should be no limitation with the scripting capability except for what can be crafted by permissions and rights management. And there should also be that scripting should also allow you to store files along with the script, so that way you don't have to download, or you don't have to create specially crafted third-party platforms to download your files from, making it easier for your applications or your computers to access those files so that they can do the necessary things for themselves. For instance, and this is where it comes into play, if you end up having to download a file, so let's say you have a particular type of scanner on your network that requires a driver, and this driver is 400 megs in size, and in order to download it every time, you have to log in to the website. But also, not only do you have to log into the manufacturer's website, the manufacturer's website is located in Japan, which your company doesn't allow communication outside of the United States. So it makes it extremely difficult to grab that data each and every time. It makes it very difficult to grab that driver. So instead of housing that driver or relying on that driver being on the manufacturer's server, you want to store that driver locally on the RMM, because you already have a pinhole to the RMM. You don't have to open it up anywhere else. You can just say, okay, everything's going to access it from the RMM. We can trust that the files on the RMM are good because of X, Y, and Z. And then you allow it to download those files. That is another aspect of a good RMM. And because you're able to have all of these files come from a predictable place, there's less overhead for security and less overhead for networking to make sure that the information has a path to get to your system, because you already theoretically have everything in place to fully utilize your RMM, or your RMM to be fully utilized by its clients. So that's another aspect of what can make a really good RMM. Other things are things like reporting. You've got to have good reporting in an RMM. Like, you can't just it's not just about seeing the devices and being able to monitor them and manage them, but it's also about being able to separate them by the kind of class of device that they're going into. Just like a transit system should identify which stops are going uptown or which stops are going downtown, or however the city identifies which direction things are going. You know, mainland, seaboard, north, south, east, west, however that city or transit system decides to identify which direction which directions a transit line is going, it should be identifiable. And in your RMM, you should be able to identify things like groups by criteria, and the criteria should be massive. That list of criteria should be massive. You should be able to list or group or identify devices by operating system version, updates installed, software installed, RAM, memory, free space on the hard drive, total space on hard drive, so on and so forth. Software installed. Man, the list goes on. There could be massive amounts of data. Any characteristic that the RMM can capture about your computer, that should be a classification that you can list on your grouping mechanism, so that you can identify devices by specific type and then therefore action on those specific devices, which is another aspect of a good RMM. Not only can you separate devices into specific groups by specific filters, but then you can action against those devices in a group. And if you can see those devices in groups and run scripts against them, then you can perform bulk actions against target systems to get them up and running. Now, last but not least of all of this kind of grouping and event logs and RMM management is you should also be able to see when operations are failing from an RMM perspective, and not only see, but there should be proper error reporting. This is something that every fucking developer forgets to do, and it's really fucking annoying. Logging should occur and let you know exactly why a thing failed. It shouldn't just say failed on the task. It shouldn't just say something like success. There should be additional data, whether it's STD out, STD error logs, whether it's designed coded logs or whatever. That information should be available to you directly as the user of the platform. You should be able to see why something failed so that you can respond accordingly. Just like if you have a service line disruption inside of a transit system, that should be reported very loudly. Like, that should be something that everybody along the transit system should be aware of, so they can avoid whatever line or whatever stops are part of this transit line disruption. And the reason for it should also be broadcast, because if you say something like, oh, well, it's broadcast because of a disruption incident, well, that's not helpful. But if you say it's disrupted because the entire subway has flooded, then yeah, that's probably going to give you a better reason to not want to go to those stops than just, oh yeah, it is just a disruption. You ignore the man behind the curtain. So these are all aspects of things that can make a transit system and an RMM really good. And, if you're in a city that has a massive amount of people and you're sitting there riding along in one of these subway cars or one of these train cars or riding on a bus or, doing any of the other things that a transit system or doing anything on a transit system, and you think about how it relates to an RMM, well, you might just be in IT and, man, go touch some grass. That's what I got to say. That's all I got time for, guys. I hope you have a great day.